This is the tutorial for Chapter 10, Section 2, titled Simplifying Radicals, and we're going to take 2 days doing this because it's a big concept. And so one of the concepts that you have to have down in order to simplify radicals, without a calculator that is to know divisibility rules. And so the key divisibility rules are going to be ones that are perfect squares, because that's what we're going to be looking for. But if you can't break something down, you can always start with something easy, like 2. Well, if it's an even number, we can divide by 2. 3 is the sum of the digits is divisible by 3, so you can see 3, 1, and 5 add to make 9, and you see how 3 goes into 9. This is the important one, though. 4, because it's a perfect square. See, the square root of 4 is 2, so we want the perfect squares. We want to be able to take those out. And the rule is, look at the last 2 digits. If the last 2 digits 4 goes into, then you can divide by 4. And so the next one that's really important is 9. 9 because it's a perfect square. Square root of 9 is 3. And this divisibility rule for 9 is just like 3, where if you sum the digits, 7, 1, and 1 make 9, 9 goes into 9. The next one I would look at is 25. It's not listed here, but 25 is one where the digits end in 25, double zeros, 75, or 50. So digits, or number ends, we'll say, number ends in double zero, 25, 50, or 75. So if we see that, then we know that 25 goes into it. And if a number ends in double zeros, well, 100 goes into that, so you can take that out as well. So let's take a look at the types of problems we're going to see. Here we have to simplify the radicals. And again, you can always check your work when we just have numbers underneath the radical sign. But here we're also going to have a variable 2, so we're going to have to be able to deal with that. So taking a look at this, I see 99 has a common factor of, well, has factors of 9 and 11. So 9 times 11 makes 99. So the rule with radicals is we can write these as separate radicals. So like the square root of 9 is times the square root of 11 is the square root of 99. And so if I go ahead and do the square root of 9, that makes 3. So 3 square roots of 11 is that solution. Looking at the next one, we've got the square root of 192s squared. So I'm going to break this into 2 different parts, 192 and the s squared. Well, starting with the 192, remember the rule with 4s. If you can divide the last 2 digits 4 goes into, I know that I can divide the whole number by 4. And I know 92 goes in there because 88 goes in there. And 88 is only 4 away from 192, or from 92. So that means, that tells me 4 goes into 192. So let's check to see how many times there. 4 times 4 makes 16, and I have 3 left over. 4 into 32 goes 8 times. So there it is, 48. So I know 4 times by 48. Now, I can break down the 48 because I see a factor of 48. 16 times 3 makes 48. So I'm going to break these into separate radicals. So 4 times 16 times 3 would make 192. And so I can see that the square root of 4 is 2, the square root of 16 is 4, and the square root of 3, well, I can't take that. I can take the square root of s squared. S squared is just going to be s. And so my answer, I'm going to multiply these 2 numbers together, I get 8. 8s square roots of 3, and that's the simplified form I was looking for. So if you just did the square root of 192 in the calculator, it would give you 8 square roots of 3, but it would not give you the s, and so that's the difference here, is that you have to understand what to do with variable terms in order to actually simplify them without the calculator. So on the next one, we have a 3 on the outside, so that just means it's already on the outside, something was already taken out. It's being multiplied by the radical of the square root of 150 b to the 8th. So on this problem, what I'll end up doing is looking at the 50, and that means that 25 goes into it. So 25 times by 6 makes 150. And then I have b to the 8th power. So I'm going to take these square roots separately here. Now anytime I've got a perfect square, I'll take that out. Like 5 is a perfect square. And I have 5 times 3 then. Well, b to the 8th is also a perfect square. It is b to the 4th. See, b to the 4th times b to the 4th makes b to the 8th. And so whenever you take out perfect squares, whenever you have an even number, even exponent, it's going to make a perfect square. So the square root of b to the 8th is b to the 4th power. And so I still have that radical sign with 6 underneath it that I cannot take the square root of. So my answer is 15 b to the 4th square roots of 6. Look at the next one. 27 has 9 as a perfect square in it. So I'm going to take that out. Now, a number that has an exponent that is not even, what we're going to do is we're going to break it down to this. X to the 8th times x to the 1st. See, those multiply to make x to the 9th. And you see x to the 8th, any even exponent is a perfect square. So I'm going to take the square roots of the parts that are perfect. So I've got negative 21 still multiplied by 3, because the square root of 9 is 3. And then I have x to the 8th is going to end up being x to the 4th. And so what's left underneath the radical sign? Well, we've got the 3x. So I go ahead and multiply these numbers, and I get negative 63x to the 4th, all multiplied by the square root of 3x. And so that's an x to the 4th. Let me make that a little more clear so it doesn't look like a 4th root. So bring it a little closer to the x there. So, and maybe put a little time sign to show that it's being multiplied by the square root of 3x. Let's take a look at the next type of problem that we'll end up seeing. And it says to simplify the product. Okay, so now we've got an extra part involved here. So what we're trying to do again is to find out perfect squares. Well, 6 doesn't have a perfect square in it, but it has some factors of 24 that go along with some factors of 6. So I'm going to bring these numbers together and try to break them down. So 2 times 3 makes 6. Well, 24, I look for the perfect squares. I see 4 times by 6. Oh, well, I have a 6 already here. See, this makes 6. And so I've got 2 6s. And you see 6 times 6 makes 36. And so I've got a perfect square there. So what I'm trying to do is find the numbers that are the same. If I have 2 factors that are the same, they're going to multiply together and make a perfect square. And that's going to give me 6. And the square root of 4, well, that gave me 2, but then I have to take a third of these numbers. Well, a third of 6, that's just 2. 2 times 2, that gives me 4. So 4 is my answer. So again, one thing I'm looking for is to see if I can make a perfect square or find a common factor that's the same. So for instance, on this problem, everything's being multiplied. I'm going to bring the negative 5 and the negative 3 next to each other, these two numbers right here. Well, I look at that 42 and I say to myself, oh, if I divide that by 2, look what I get. I get 21. Well, I already have a 21. And 21 times 21 ends up making 441 if I multiply those two numbers together. But I don't even need to really do that because I know once I go ahead and multiply them and then take their square root, it's just going to make 21. So when I do this next time, I'm just going to, instead of multiplying them together, I know that if I have a square root of 21 times 21, that's just going to make 21. And so now I have 21 times by 15. And let's see here, that's going to end up giving me 21, 15, that gives me 5, 10, and I carry a 0 down, that makes 1 and 2, and those add to make 3, 1, and 5, 315. So 315 square roots of 2. Well, look at the next one. I do the same sort of thing. 128 has a pretty good sized number, but I see that 4 goes into the into 28. So I'm going to do 4 into 128. Well, 4 goes into 12 3 times. It goes into 8 2 times, so 32. So now I've got 2y, those are underneath the radical sign, and I'm going to bring this other y to the 5th next to it, and I'll combine those together in just a moment. And so I have 4, which is a perfect square, and then 32. Well, 32 is not a perfect square, but there is a factor that is. 16 is the big number that goes into 32. And I have that 4, and these are still all underneath the radical sign. And then over here I've got a 2, and I'm going to combine these two together, y to the 6th. And so now I'm going to go ahead and take some square roots. So I got the square root of y to the 6th is y to the 3rd. So y to the 3rd times y to the 3rd makes y to the 6th. Square root of 4 is 2. Square root of 16 is 4. And what I've got left is the 2 and the 2. Well, those make 4. And so the square root of 4 is 2. So I have that other 2 I can bring out as well. So it looks like I have no more radicals. Just got to multiply these numbers together. So 16y to the third is that answer. Well, taking a look at this next one, I've got 12 and 6. Well, 12 has a perfect square in it. 12 has 6. So 6 times 2x to the third. And then over here, I've got the 6 times x to the third. That's all underneath the radical sign. What's outside is the 10 and the 2. So I'll make a little division here of these two problems. So again, underneath or outside the radical sign, I've got 20. Inside the radical sign, I've got the 6 and the 6, which make 36. So that will make a square root of 6, or a square root of 36, which just makes 6. X to the third, well, that makes x to the 6. So when I take the square root, I get x to the third. And so the only thing I have left underneath the radical sign is the 2. And so I go ahead and multiply these numbers together. I get 120 x to the third square roots of 2. Well, let's take a look at the last type of problem that we'll end up seeing. A couple word problems here. And so it says that a pool is shaped like a rectangle with a length of 4 times its width. So let's go ahead and draw the rectangle. And we've got, it says that the length is 4 times the width. And I got that because it says length is 4 times its width right there. And so here's the width, and it says what expression could represent the distance between the opposite corners of the pool. Okay, so this point to this point here, what is that? Oh, well, there's a right triangle. We've got Pythagorean's theorem here. So we're going to set it up as this. We got the two legs, w squared plus 4w in parentheses squared equals, we'll call it, how about x squared. And so I go ahead and do some work there. I get w squared plus 16w squared, or a w squared, equals x squared. So I combine these together, I get 17w squared equals x squared. Well, to find out what the answer of x is, I have to take the square root. That's going to cancel out the squared symbol. So what I've got is the square root of 17w squared equals x. Well, I've got to simplify that. And w squared is a perfect square. So w square roots of 17 equals x. And those are just in units. And that is the simplified form. So don't know what the units are, just said that the width is 4 times, or length is 4 times the width. It says Evelyn rode her horse along a triangular path. The distance she traveled south was, okay, distance south, was 5 times the distance she traveled east. Okay, east would be in this direction. So it went south and then east. We don't know how far east. We'll just say d for distance. And so we want to find out, then she rode directly back to the starting point. So she did this. So what we've got, since she's going south and east, that makes a right triangle. And we're trying to find out what that distance is. And so we have the same thing. 5d quantity squared plus d squared equals x squared. So when I do this work, I get 25d squared plus d squared equals x squared. And this makes 26d squared equals x squared. So when I take the square root, it's going to cancel out that squared symbol, leaving me with d times the square root of 26 equals x. And don't know what those units are, so I'm going to go ahead and leave that as that answer. So now we know what the distance east, or the distance back is d times the square root of 26. So now what we want to do is find out what is the total distance. So total distance she rode. So we're going to do 5d plus d square roots of 26. That's going to give us the total distance. Well, this makes 6d, and then I have plus d square roots of 26. So if I wanted to do something here, I could go ahead and factor out a d, since both of them have that variable there. So I'd have d, and then multiplied by 6 plus the square root of 26 equals x. And those are units. Don't know what those units are, so I'm just going to leave it in this simplified form. So those are the types of problems you'll see on today's assignment.